Hi, and welcome to Agyei-Boateng's classroom. Today we're going to be learning property of logs. Um, so let's start off by explaining what you will use property of logs for. You would most likely use them to solve really complex equations or just maybe simple equations. They help, they're shortcuts, and they're just rules that you really have to know. So let's start with the first one. Oh wait. Log A of x times y equals log A of x plus log A of y. Okay, this property explained is, it reads out, the log of a product can be expanded to a sum of two logs that have the same base. So if you notice, you need the same base before you can expand it. Log A. If you look at it from right to left, it is being condensed. If you look at it from left to right, it is being expanded. Let me try to write it out. This is being expanded. This is being, condensed. It's an O. You'll see that as relevant when we work on a problem later on. Okay, so the next property is, let me switch back to my color, log base A of x over y is equal to log base A of x minus log base A of y. Again, same concept. This way it's expanding, this way it's condensing. Okay, so let's just focus on these two right now and try to work it out. So if we look at it in problem form, it would look something like this. Let's say you're asked to expand this problem using your properties, right? Well, let's figure out a problem first. Log of 16 plus, over, over, let's say 24, right? Okay, first of all, there's no base that is explicitly written. So what does that tell us? That tells us that it's an implied base 10. So if we're expanding, we're going to go back to our rules because this is a division problem, okay? So we're looking at this right here. And so we're going to say, This is in the condensed form right now, and to expand we got to move this way. So we got to get something that looks a little bit like this with the subtraction problem in the middle. So using the same basis, which is base 10, we're going to write out our answer. So our answer would look like something like, this. Log of 16 minus log of 24. Now, this seems simple right now, but it gets a little complicated because they like to throw in the other properties and use all the properties at once, but we're going to focus on the minimal stuff right now. Let's say they tell us to condense, right? So this is the hardest word to write on the software. To condense, and they give us a problem that looks like this. Log base 7 of 9 plus log base 6 of 9 equals, first of all, you should not even try to go back to your rules because these two have different bases. Thus, you are not going to get an answer. They have to be the same basis in any of the problems. Like this one had a base 10. The first one had a base 10, so we carried the base 10s. This one, it needs to have the same base. So the problem needs to look a little bit like this. Log base, colors, 7 of 13. Now we can condense it because our bases are now the same. So when we condense it, we get what? Let's go back to our rules. We're looking at an addition problem, and when you condense it going this way, it turns into multiplication. So we're going to do just that. Oh, dang it. What did I do? Oh, clicking on the wrong layers. Okay, so we said that when we condense addition, it turns into multiplication. So let's just do that, and we should get log base 7. Keep your bases, guys, of 9 times 13. You can simplify that down to log base 7 of, let me double check with the calculator, 117. Okay, so now that we know how to figure those out, let's move on to our next set of rules. Okay, I think I can squeeze in one more into this. Okay, this is our exponent, logs and exponents. So log base a of x to the power of r equals r log base a of x. I want you to tell me what happened to this r in the exponent form. Think about it, because in this, it's up here, right here, it became a coefficient. Let's read the explanation. If you take the log of something related to an exponent, the exponent can be moved in front of the log. I think that makes it a little easier, especially when you're trying to solve for x or solve for a number during your equation. So yeah, good tool to have. Yeah. So same thing. This is the expanded. This is the condensed. Okay, let's try it out. So actually, let's start a new layer. Let's say you are giving, we'll do an expand and condense for this. But let's say you're given the equation log base 24. Okay, log base 2 to the power of 4 squared, right? And they want you to expand. I should probably change colors. Expand. I promise you that says expand. I just don't know how to write right now. So let's go back to our properties. And they tell you to expand, we're going this way. So it's gonna be our exponent in the front of the log now instead of on top in the exponent area. So how about we go ahead and do that? So now it's gonna be log, oops, I said it's gonna be in the front of the log, and look what I did. I really don't like how that looks, but we know to expand now. So this 2 is gonna move to the front, so it's gonna turn into 2 log, keep everything else the same, base 2 of 4, right? Good stuff. If they tell you to condense that, they would probably start off with 2 log base 2 of 4. Ask you to condense that, you would get, move your 2 back into its exponent form right here, so you would get log base 2 of 4 to the power of 2. Good stuff, boys and girls, good stuff. How about we try one more property, and actually 2 more. And this is very, very essential, actually. It's nice to have these because it saves you time from doing actual work. So let's start off. So it reads, whoopsie, actually, log base A of A equals 1. Now, why is that? Well, you know that, well, let's read the explanation. It says, if what you're taking the log of equals the base, then the expression equals 1. So, essentially, if you see, let's work it out actually, instead of just telling you. If you see, let's say log base 3 of 3, automatically know it equals 1. Why? Because the base is the same as the number you are taking the log of. Same concept with bigger numbers. It doesn't matter if it increases. log base 35